Now let's come back to the converse of the previous property. Triangles on the same base and between same parallels are equal in areas. And parallelograms on the same base and between same parallels are equal in areas. Now the converse of that theorem. So how do we define the converse? So let's state the converse. My question is, will parallelograms on the same base, which are on the same base, and having equal areas, the two parallelograms or any number of parallelograms on the same base and having equal areas lie between is what I have a question as converse. Will parallelograms on the same base and having equal areas lie between the same parallel lines is the biggest question out here. So let's see the converse of the previous theorem, investigating the converse of same bases and same parallels. Now let's take two parallelograms with the same base and lying between two lines which are not parallel. So the converse clearly says that if I have the same base AB and if I have two parallelograms lying, let me say there's another line L which is not parallel to this but a bit away from the base AB. Now let me take two parallelograms in this case. So one of the parallelogram is formed by the line L, which is A, B, C and D. So A, B, C, D is a parallelogram which is formed with the base AB and the line L. So here is the parallelogram. Now with this parallelogram, let me take another parallelogram which has the same equal area. The condition for converse is that they lie on the same base. So taking the same base AB, I'll draw another parallelogram which has equal areas and same base. So let me take another parallelogram of the same equal area between the line L and the line AB, the same base AB. So here is the same base AB. This is the same base. So therefore, I take another parallelogram out here, AB, EF. So here I have another parallelogram AB, ABEF out here. So here is the parallelogram ABEF between the same base AB and between the line L and the base AB with equal area. So here ABCD and ABEF are the parallelograms on the same base AB, which is out here, are parallelograms on the same base AB and between the lines L and same base, and between the line L and same base AB. So between same base and the line, there are two parallelograms ABCD and ABEF which are equal. Also, area of parallelogram ABCD equals area of the other parallelogram, which is ABEF. So area of parallelogram ABCD is equal to area of parallelogram ABEF. So you have taken parallelograms having equal areas as per the converse of the statement. Now, when in such case of two parallelograms lying on the same base and with equal areas, will the lines be parallel? Is the question out here. The converse of the theorem clearly says, as supported by mathematics, that they must be parallel. Two parallelograms lying on the same base and which are in equal area must be between the parallel lines. That is, this must be equal to this. Is how we understand the converse of the theorem. So here, that implies the line L is parallel to the base AB. So we have a property which says triangles, parallelograms on the same base and with equal areas must lie between the parallel lines. That's how we understand the converse of the previous theorem. Converse holds true in this concept. Two parallelograms between two parallel lines.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.